30% of people own a talk to phone. People are selected at random, one at a time, and asked whether they own a talk to phone. The number of people questioned, up to and including the first person who owns a talk to phone, is denoted by X. This shows that this is going to be a geometric distribution problem where probability of success is 30%, 0.3, hence probability of failure is 0.7. Probability of failure is also represented by 1 minus p. Okay. In part 1, we have to find probability x is equals to 4. That means first 3 would be failures followed by a success. So 0.7 cubed times 0.3. This gives 0.103 as our rounded 3 significant answer. You should ideally be writing a longer answer followed by the rounded answer. Okay. Next is probability x is greater than 4. The formula for that is just q power 4. This is the actual formula. Probability x is greater than r is equals to qr. So we're going to write q power 4, which gets us 0.240. And in part 3, we have to find probability x is less than 6. The formula for probability x is less than and equals to r is 1 minus qr. But if we have to change it into less than sign, then we reduce r by 1. And the formula changes into this. R becomes r minus 1. So we're going to change this into probability x is less than and equals to 5, which is equals to 1 minus q power 5. So 1 minus 0.7 power 3, which is going to be, I'm sorry, 5, not 3, which gives 0.832 after rounding. Andy makes repeated attempts to thread a needle. The number of attempts up to and including the first success is denoted by X, showing that this is geometric distribution. Part 1, state 2 conditions necessary for X and to have a geometric distribution. Okay, so the 2 conditions would be that each outcome is independent. Outcome is independent. And the probability of success is fixed. Probability does not change. Probability of success and probability of failure will not change. P will always be 0.3. We don't know that yet. So P and Q will not change. Okay. And then there's another condition, that is there are only 2 outcomes. There are only 2 outcomes. That is, the thread would either go through the needle hole or it will not. Okay, so that's the answer for part 1. Part 2, assuming that X has a geometric distribution with probability of success at 0.3, which means probability of failure is 0.7. Part A, find probability X is equals to 5. That is, the first time success happens is on the 5th attempt. So we will write q power 4 times p. So 0.7 power 4 times p, 0.3. This gives 0.072 after rounding. And then we have probability x is greater than 5. The formula for that is q power 5. So 0.7 power 5, which gives us 0.168. Part 3. Suggest a reason why one of the conditions you have given in part 1 might not be satisfied in this context. Okay, so in part one, we said that one of the conditions must be that each outcome is independent. But that not might not be true because a person might actually get better with experience, and then the probability of success would technically get improved. So you can write that person can get better with experience, hence outcomes not independent, and may become greater than zero point 0.3 after some time. Okay. R and S are independent random variables, each having distribution, geometric distribution with probability of success P. Find probability R is equals to 1 and S is equals to 1 in terms of P. Okay, so if they're independent, then probability R and B, which is also represented by an intersection symbol, is actually equals to probability of R times probability of S. So in this case, it will be probability R is equals to 1 times probability S is equals to 1. Is equals to 1 means that on the first attempt, there's a success. So that's just P, and this will be P as well. So the answer will be P squared. Okay. In part two, we have to show the same for r is equals to 3 for and s is equals to 3. So we're going to do times probability s is equals to 3. This means that the first success happens on the third attempt. So first two would be failures and then there would be a success. So failure is represented by q. So q squared p, and again for s, q squared p, which gives us q power 4 times p. Okay, p squared, I'm sorry. And that's what we were supposed to show. And also we know from before that q is 1 minus p. So better to mention that as well. Okay, part 3, use your formula to form sum to infinity of the use the formula for the sum to infinity of a geometric series to show that probability R is equals to S is equal to this. Okay, so sum to infinity has a formula which is given in the formula sheet, which is A over 1 minus R. Okay, so let's look at our sequence. At R is equals to 1 or S equals to 1, we had P squared. Then for R is equals to 2 and S is equals to 2, we'll have a failure and a success times a failure and a success, both for R and S is equals to 2. So that becomes Q squared P squared, or P squared Q squared. And then for R is equals to 3, we had gotten this. R and S is equals to 3, we got P squared Q power 4. Okay, so now we can see that A is P squared, and the common ratio here is what is multiplying every time? Q squared is multiplying every time. So R is equals to Q squared. So we're going to write P squared over 1 minus Q squared. And Q was actually 1 minus P. Here there's no Q, so we must change P into Q into P. So P squared upon 1 minus Q is 1 minus P whole squared. Okay, now I'm going to expand the denominator using the identity minus sign. A square minus 2ab plus b squared. This simplified gives us p squared upon 1 minus 1 plus 2p minus p squared. So I'm going to take p common, and we get 2 minus p in the bracket, p and the square cancels out, and we get p upon 2 minus p. That is what we had to show. Question number 9. Sandra makes repeated independent attempts to hit a target On each attempt, the probability that she succeeds is 0.1. Okay. Find the probability that the first time she succeeds is on her fifth attempt, which means we'll have failures in the first four attempts, followed by a success. Probability of success is 0.1, and probability of failure is 0.9 for Sandra. So we'll write 0.9 power 4 and z times 0.1, which gives us 0.0656. Okay, part B. The first time she succeeds is after her fifth attempt. So this is what they're asking for. We know the formula for that. It is Q power 5. So Q is 0.9 power 5, which gets us 0.590. The second time she succeeds is before her fourth attempt. Okay, now what does this mean? The second time she succeeds is before her fourth attempt. So that could mean that maybe she failed the first time, then she uh, was able to hit the target, and then she succeeds again, was able to hit the target. So this is one of the cases in which the second time she succeeds is before her fourth attempt. So, or we could also do uh, P, Q, P. That means success, failure, success. Or we could also do P, P, and Q. In fact, we can also do success, success, and success. That would also work. So we're going to, because even in this case, the second time she succeeds is before the fourth attempt. So now we're going to add and multiply all these probabilities. It's 0.7 times 0.1, sorry, 0.9 times 0.1 squared. And it's the same here and it's the same here. So I'm going to times this with 3 plus 0.1 square cube for P, P, and P, which gets us 0.028. Next is Jill also makes repeated attempts to hit the target. Each attempt of either Jill or Sandra is independent. Each time that Jill attempts to hit the target, the probability that she succeeds is 0.2. That means probability that she fails is 0.8. Sandra and Jill take turns attempting to hit the target, with Sandra going first. Part 2. Find the probability that the first person to hit the target is Sandra on her second attempt. Okay, that would mean that in the first attempt, it's Sandra's turn, but she misses. The next attempt is Jill's turn, and she also misses. And the third turn is Sandra's turn, and she hits. So probability of this happening would be Sandra missing is 0.9, then Jill missing is 0.8, and then Sandra hitting is 0.1, which gives 0.072. Okay. Next is that the first person to hit the target is Sandra on her 10th attempt. That means in the first attempt, Sandra misses and Jill misses as well. Both of them miss, and this keeps happening 9 times. So I'm going to give that a power of 9. And on the 10th attempt, Sandra hits the target. So 0.1, times 0.2, sorry, 0.9 times. Sandra missing to hit the target is 0.9. Probability that Jill misses the target is 0.8 power 9 into probability of success for Sandra, which is 0.1, which gives us 0.0052. 60% of voters at a certain polling station are women. Voters enter the polling station one at a time. The number of voters who enter up to and including the first woman is denoted by X, which shows this is a question on geometric distribution. State a suitable distribution that can be used to model X. So we can start by writing X follows geometric distribution, and we have to write probability of success here, which is 0.6. 60% is 60 over 100, which is 0.6. Okay, giving the values of any parameters, done. The parameter is 0.6. State also any necessary conditions for this distribution to be a good model. Okay, so the three conditions are that there are only two outcomes. Woman or man. Then we have probability of success is fixed. Probability of woman and man is fixed. So probability that it's a woman is 0.6. Probability that it's a man is 0.4. You can write that down. And it's always stays the same throughout the question. And third condition would be each event is independent. Each outcome is independent of the previous outcomes. Okay, part 2. Use this distribution stated in part 1 to find probability x is equals to 4. So the formula for that is QQP, that is failures the first 3 times and then a success, which will give us 0.4 cubed times 0.6. Which gives us 0.0384. And for part 3, we're going to use the formula probability x is greater than 4 is equals to q power 4, which is 0.4 power 4, which gives us 0.0256. The score when two fair six-sided dice are thrown is the sum of two numbers on the upper faces. Show that probability that the score is 4 is 1 by 12. Okay, so how do we get a 4 by throwing a dice twice or throwing two fair-sided dice? That would be by getting a 2 and a 2 in the two throws, or which is plus, there could be 1 and 3, but then we'll times it with 2 because it could also be 3 and 1. Okay, so probability of getting a 2 is 1 by 6, another 2 is 1 by 6 as well, then 1 by 6 for getting a 1, and then 1 by 6 for getting a 3, and we double it, and all of these combined would give us 1 by 12. This gives us 1 by 12. Okay, part B. The two dice are thrown repeatedly until a 4 is obtained. Okay, so this means this is geometric distribution. The number of throws taken is denoted by random variable x. Find the mean of x. So for geometric distribution, mean is 1 over p. So p in this case is 1 by 12. So the failure in this case would be 11 by 12. Anyway, 1 over p would be 12, which is the mean. Part C, find the probability that a score of 4 is first obtained on the sixth row. This is probability x equals 6, which is failure the first 5 times followed by a success. So 11 by 12 power 5 times 1 by 12, which would give us 0.0539. Then this part D, probability x is less than an 8. That would be the formula that we would use is probability x is less than and equals to r. That is equals to 1 minus qr. To change this into equals to, you will have to reduce 8 by 1. That gives us 7. So our formula becomes 1 minus q power 7, which gives us 0.456. An ordinary fair die is thrown repeatedly until a 1 or a 6 is obtained. So what is the probability of this happening? Probability of 1 or is plus probability of 6. So that's going to be 1 by 6 plus 1 by 6 or directly 2 by 6 as well, which will be 1 by 3. So in this question, our probability of success is 1 by 3, which means probability of failure would be 2 by 3. Okay. Find the probability that it takes at least 3 throws but no more than 5 throws to obtain a 1 or a 6. So it takes at least 3 throws, so greater than equals to 3, but no more than 5 throws, so less than 5. Okay, this would mean that we'll calculate x equals to 3 plus probability x is equals to 4. Okay, that would be q squared p plus q cubed p. So q squared p would be 2/3 squared times 1 by 3 plus 2/3 cube times 1 by 3, which gives us, okay, I made a mistake. It says, but no more than 5. So it could also be 5. So probability x is equals to 5 also needs to be included, which would be q4p. So plus 2/3 power 4 times 1 by 3. Okay, so this would combine give us 0.313. Okay, that's part A. On another occasion, this die is thrown 3 times. The random variable x is the number of times that a 1 or a 6 is obtained. Draw the probability distribution table for x. Okay, so the die is thrown 3 times. And we have to draw probability distribution table. For this, we'll write x here and probability x equals to 1. So we're going to first write 0. That when a dice is thrown 3 times, 0 times a 1 or a 6 is obtained. And then we'll write 1, that when a dice is thrown 3 times, 1 time a 1 or a 6 is obtained, then 2 times, and then it could happen 3 times. Okay, now we have to find each of these probability. So 1 or 6 has a probability of success of 1 by 3 as calculated earlier, and probability of failure of 2 by 6, 2 by 3 as calculated earlier as well. Okay, now this becomes a question on geometric distribution, that Out of the three turns, something happens 0 times, or 1 time, or 2 times, or 3 times. Formula for that would be out of 3 times, there's a zero success. So we write success here, which is 1 by 3 power 0. And that would mean there are 3 failures. So we write failure here and power 3 minus 0, which is 3. Plus, out of the 3 times, there's only one success. So probability of success, power 1, probability of failure, power 2. Then out of the 3 times, success happens twice. Probability of success is 1/3, power 2. Probability of failure is 2/3, power 3 minus 2, 1. And out of the 3 attempts, success happens all 3 times. So 1 by 3, power 3, and then 2 by 3, power 0. Okay, we need to find all these individual properties. That's for 0, that's for 1, that's for 2, and that's for 3. We're not supposed to add them. That was a mistake, writing plus sign in between. Okay, so for 0, we're going to get 8 by 27. So we write that here. For 1, we're going to get 12 by 27. For 2, we're going to get 6 by 27. And for 3, we're going to get 1 by 27. Okay. That's our probability distribution table. Next, we have to find the expected value. It has a formula given in the formula sheet, which is just x times p. So we're going to multiply each x with its probability and keep adding them. So 0.313. I'm sorry, that gives a 1 actually. This is equals to 1. Kayla is competing in a throwing event. A throw is counted as a success if the distance achieved is greater than 30 meters. Probability that Kayla will achieve a success on any throw is 0.25. Find the probability that banana takes more than 6 throws to achieve a success. Okay, so we need to find probability x is greater than 6, formula for which is q power 6. This is geometric distribution, by the way. So P is going to be 0.25, which means failure is going to have a probability of 0.75. And we are going to substitute that in the formula, giving us 0.178. Part B. Find the probability that for a random sample of 10 throws, Kayla achieves at least 3 successes. Now, this is binomial distribution. So, out of the 10, there are 3 successes. So, we're going to write P power 3, so 0.25 power 3, and failure power 10 minus 3, which is going to be 7, which gives us. Okay, I'm so sorry. I did not read the question properly. It says at least 3 successes. So it could be 3 successes, or 4 successes, or 5, or 6, or 7, or 8, or 9, or 10, actually. So we can't be doing all of this. 4 would mean we would add 4 here, 5 would mean we would add 5 here, and we would need to keep adding them. So that's a bad approach. Instead, what we can do is we can do 1 minus probability there's no success, or there is one success only, or there is 2 successes only. So if we add these and then subtract the answer from 1, that will give us the same result as adding 3 successes plus 4 successes plus 5 successes all the way till 10 successes. So 1 minus 10C0, probability of success, power 0, probability of failure, power 10. Okay, there's supposed to be a bracket here, plus 10C1, 0.25 power 1, 0.75 power 9, plus 10C2, 0.75, sorry, 0.25 power 2, and 0.75 power 8. Which gives us 0.474. An ordinary fair die is thrown until a 6 is obtained. So probability of success is 1 by 6. That means probability of failure would be 5 by 6. Find the probability that obtaining a 6 takes more than 8 throws. So this is geometric progression. Probability x is greater than 8 is q power 8. So 5 by 6 power 8. This is supposed to be an 8. Gives us 0.233. Part B. Two ordinary fair dice are thrown together until a pair of 6 is obtained. The number of throws taken is denoted by random variable x. So now two ordinary dice is thrown. So then probability would be of getting a 6 and a 6 would be 1 by 36. Okay. Find the expected value of x. Okay, this also means that failure would be 35 by 36. Failure would have a probability of 35 by 36. And this is also geometric progression because it says geometric distribution because it says that until a pair of 6 is obtained. So couple of failures followed by a success. Okay, so the expected value has a formula of 1 upon p, which is going to be reciprocal of p, which is 36. Okay. Next is find the probability that obtaining a pair of 6 takes either 10 or 11 throws. So we're going to find probability x is equals to 10, or means plus probability x equals to 11. X equals to 10 means failure 9 times, so 35 by 36 9 times, followed by a success, which is 1 by 36, plus x equals to 11 means failures 10 times, followed by a success, which would give us 0.0425. A fair six-sided die with faces marked 1, 2, 3, 4, 5, 6 is thrown repeatedly until a 4 is obtained. So a question on GP, probability of success would be getting a 4, which is 1 by 6. Probability of failure would be not getting a 4, which would be 5 by 6. Find the probability that obtaining a 4 requires fewer than 6 throws. So probability x is less than 6, which has to be changed into probability x is less than and equals to 5, because the formula that we have is for x is less than and equals to r, which is equals to 1 minus qr. So this will be equals to 1 minus q power 5, which gives 0.598. On another occasion, the die is thrown 10 times. That means this is now going to be binomial distribution. Find the probability that a 4 is obtained at least 3 times. So this is going to be binomial distribution like discussed. Out of the 10 times, success happens at least 3 times. So that could be probability x equals to 3 plus probability x equals to 4 plus probability x equals to 5 all the way till probability x equals to 10. That is a lot of work. Instead, we'll do 1 minus probability x is equals to 0 plus probability x equals to 1 plus probability x is equals to 2. So 1 minus x is equals to 0 would mean out of the 10 times, 0 times there's a success. Success was 1 by 6, probability power 0, and failure was 5 by 6, and this will happen 10 times, so power 10 plus 10c1. Out of the 10 times, 1 times, we get a 4. So success happens once and failure happens 9 times plus 10c2. Success happens twice, failure happens 8 times, and all of this will give us 0.225. A fair spinner with 5 sides numbered 1, 2, 3, 4, 5 is spun repeatedly. The score on each spin is the number on the side on which the spinner lands. Part A. Find the probability that a score of 3 is obtained for the first time on the 8th spin. Okay. Scoring a 3 is a success, which will have a probability of 1 by 5. That means failure is not getting a 3, which would be 4 over 5, which will have a probability of 4 over 5. And you get your first success on the 8th spin means this is a question on geometric distribution, that you get failures the first 7 times followed by a success. So 4 by 5 power 7 followed by success, which has a probability of 1 by 5. This gets us 0.0419. Next part says, find the probability that fewer than 6 spins are required to obtain a score of 3 for the first time. So we know the formula for probability x is less than and equals to r, which gives us 1 minus qr. So we will have to rewrite this and with an equals to sign. So this would become 5. You always reduce this by 1. Okay, now we can write it as 1 minus q power 5. So 1 minus 4 by 5 power 5, which gives us a 0.672.